tangent graph. Now, you already know what sine and cosine looks like. Let's start to graph it right here. So since you already know what sine and cosine looks like, graphs that I've already shown you, let's talk about what the tangent looks like. Well, let's take a look. The tangent function is a ratio of sine over cosine. So we'll draw our Cartesian coordinate plane here. Here's theta axis, and here's the, what you would call f of theta axis. All right, tangent has asymptotes at special values of pi over 2 and negative pi over 2. Let me denote that here real quick. Why are there asymptotes in the tangent graph at this location? Well, it's pretty clear. It's due to the fact that tangent of theta is equivalent to sine of theta divided by cosine of theta. Why does that lead to asymptotes at pi over 2 and negative pi over 2? Well, notice that tangent of pi over 2 is then sine of pi over 2 divided by cosine of pi over 2. Notice that this is equivalent to sine of pi over 2 is 1, cosine of pi over 2 is 0. We have division by 0, so this is undefined. So at this point, pi over 2, it is a non-allowable input. So it's not in the domain of tangent. Therefore, we put an asymptote there. And furthermore, along the same token, tangent of negative pi over 2 is really the same thing as a sine of negative pi over 2 over cosine of negative pi over 2. Notice that sine is an odd function, so we get this. And notice cosine is an even function, so we get this. But still, this results in negative 1 over 0, which is still negative undefined, if you will. Where this is positive undefined, or air quotes positive infinity, this is negative undefined, or air quotes negative infinity. Okay? Air quotes meaning not really, but you can kind of think of it like that in terms of understanding what the graph is about to do. The tangent graph looks like this. Where at, let's say pi over 4, it's at 1. It's at the height of 1. And at negative pi over 4, it would be at negative 1. Okay? Because sine over cosine of pi over 4 is root 2 over 2 divided by root 2 over 2. Anything divided by itself is 1. And so that's why that's the case. So here we have the tangent graph. F of theta is equal to tangent of theta. All right? So this is the simple tangent function. Now let's think about what happens to tangent when we have arbitrary differences in its shifts. Meaning we know how to graph an arbitrary sine or a cosine, but what about tangent? First off, let's note that the period of tangent, the normal tangent of theta, is pi. So as opposed to sine and cosine, which both have period 2 pi, tangent has period pi. Now, what about something like this? What about if we have instead of tangent of theta, what if we have y of x is equal to tangent of, and I said x, so I'll change that to theta since we have a theta on our axis right here. So y of theta would be tangent of theta plus a pi over 4. How do we deal with this? Okay, well, notice that first, the general form of a tangent, y of theta, will equal a tangent of b theta minus c plus d. D is the vertical shift. Your period will be determined by b theta minus c. Notice that we will say that we restrict that b theta minus c be between the two asymptotes of the parent graph between pi over 2 and negative pi over 2. I'll explain what I mean by this in a little bit. Also, a, absolute value of the value a, is your amplitude. And we can find this period like so. So in this case, amplitude is equal to A is equal to 1, our B is equal to 1, our coefficient in front of theta is 1. Notice that our C is equal to negative pi over 4, because in the standard form, there's a minus on the C. If you notice that there's a plus sign here, that means that pi over 4 was negative to undo the minus sign. So that's why we put minus pi over 4. And D here is 0. We don't have to worry about a vertical shift. But notice the tangent of theta plus pi over 4 has a trivial amplitude, and we will now utilize this inequality to figure out its new period, if it is a different period than pi at all. So notice we replace b theta minus c here with its corresponding values. B is 1, theta is theta, minus c. What is our c? As a negative pi over 4. Okay, hence that plus pi over 4, and it's bounded by pi over 2, pi over 2. Notice that now I get this. So I subtract the pi over 2 from both sides, pi over 4 from both sides. So minus pi over 4 from all three sides, minus pi over 4, minus pi over 4, minus pi over 4. It's not multiplication, it's subtraction, so there's no sign flips going on. So then I get negative pi over 2, minus pi over 4 over here. This bounding theta, and over here I get pi over 2 minus pi over 4. And so over here, we get negative 3 pi over 4. And over here, I get pi over 4, because multiply top and bottom here by 2. I get 2 pi minus a pi over 4. That's pi over 4. Okay? So now we know that the range of theta is restricted to almost pi over 4 or almost negative 3 pi over 4. So notice that from here to here, to get to here, I not only have to add a 3 pi over 4, but also that makes me go to 0, then I add another pi over 4 to get across the whole interval, meaning that the whole interval spans a distance of pi. So that shows you that the two asymptotes are a distance pi away from each other, meaning that the new period is in fact still pi, and it did not change.